Now that we know what z-scores are conceptually, let's go ahead and walk through a few calculations. Remember that z-scores are the number of standard deviations a particular score is from the population mean. So in other words, we're converting our raw values, whether it be dollars or feet or inches or pounds or whatever it may be, we're converting it into standard deviations. We call those z-scores. So once we have those, we can again compare individual scores to the overall population, and we can also compare scores from different populations. So we'll focus on comparing individual scores to populations first, and we'll talk about comparing across different populations later. Now, with the normal distribution, we always have to start in the center of the distribution. And the reason why is, as you can tell, the distribution never actually touches the x-axis. In other words, it asymptotes. So it gets closer and closer to the x-axis, but it never touches it. So there's really no beginning point to the distribution, and there's no ending point to the distribution because it's infinite. So we always start at the center and we build outwards from the center. And so you see where this blue arrow is, that is the center of our distribution, and that is where the z-score is 0. So in other words, there's no deviation from the mean of the population, and so there's a 0 standard deviations or 0 deviations. So that's a z-score of 0. Now if we look at where the blue arrow is, we have moved from the mean or the center of the distribution to the left 1 standard deviation. So in other words, that is a z-score of -1. We have subtracted 1 standard deviation from the center of the distribution. So that would be in the negative direction 1 standard deviation. So that would be a z-score of -1. If we look at where the blue arrow is now, we'll see that we have moved from the center of the distribution, where z-score is 0, and we've added 2 standard deviations. And so we would say that this is a z-score of 2, or 2 z-scores. So it's 2 standard deviations above the mean, or above a z-score of 0. Conceptually, that's easy enough. Now let's take what we've learned and now let's apply it to a formula for calculating specific z-scores given a mean and a standard deviation. So here's our formula. So z stands for z-score. It equals x minus mu, notice that that's in parentheses, so that's what we need to calculate first, divided by sigma. And again, sigma is the standard deviation, mu is the population mean, and x is the individual value in our data set. So we'll take an individual score or an individual value, and we'll subtract the mean, and again this is in terms of raw scores or in terms of the unit of measurement that we collect the data in. So we'll take individual score, we'll subtract the mean of those scores, and we'll divide by the population standard deviation. And that will give us a z-score. Alright, so let's go through an example. So here we're going to convert height into z-scores. And so this is based on data I've collected from previous classes. So based on data from previous classes, we can say the population mean is 67 with a standard deviation of 4.13 inches. So we're talking about inches here. And let's say we have one student in the course who is 71 inches tall. And so 71 inches tall would be 5 feet 11 inches. Alright, so here's our values and here's our formula. So in place of x, we would put the actual score or the height of that student, 71 inches. We would then subtract the height of that student from the population mean, or the height for the population. In this case, the average is 67 inches tall. So we'll take 71 minus 67, and that's going to be the numerator. And again, we always want to start with what's in parentheses first. So 71 minus 67 is a difference of 4 inches. It appears this one particular student is 4 inches taller than the average of students in the Stats 2010 course. So we have 4 in the numerator, 4 inches, the difference between the height of the student and the height of the average student in the course, and we'll divide it by the standard deviation. So remember, the standard deviation is the typical or average deviation we can expect from students within a population. And so the average deviation, the average difference among students, is about 4.13 inches. So we'll divide by the standard deviation. We'll take 4 for the numerator, divide by the standard deviation of 4.13, and that will give us our z-score. In this particular example, our z-score then would be 0.97. So almost 1 standard deviation above the mean. And that would make sense because remember, our individual student was taller than the average. It was 4 inches taller than the average student. And so it should be somewhere around a z-score of 1. Remember that average deviation was 4.13. This one student was 4 inches taller. So that's pretty close to 1 standard deviation above the mean. And that's what we see here. The actual z-score, the precise z-score, is 0.97. And that's almost 1 standard deviation above the mean. And so we can say that this one particular student, instead of saying that the student is 71 inches tall, we can say that this student is 0.97 standard deviations or 0.97 z-scores above the average height of students in the Stats 2010 class. So to calculate a z-score, we take an individual number or score and we subtract the mean of the population and we divide by the standard deviation. But what if we wanted to know the height from, let's say, a z-score? So in other words, we want to reverse the formula. Much like a raincoat on a cute little kitten, we want to now look for the raw score, in this case height, when we're given a z-score. So again, the formula is reversible. We just use algebra to reconfigure the formula, and now we can solve for height or for the raw score. So here is our new formula. We've used algebra to now solve for x rather than for z. So now we have x equals the z-score times the standard deviation plus mu, or in other words, plus the population mean. And so now we can solve for an individual height in terms of inches, which is x. Remember, an individual score is x. And we can do that by taking the z-score that's given to us, multiplying by sigma, the standard deviation, and adding mu, the population mean. So let's go through an example. So let's say someone has the height of a z-score of 0. So again, instead of given inches, we're told that this particular person has a height of a z-score of 0, or 0z. What would be the height of that particular student? Well, we could take that z-score, 0, put it in place of z in our formula, then replace our standard deviation, which is 4.13, and we multiply those two together. So 0 times 4.13 would be 0. And so not surprisingly, because we've talked about this before, that when we have a z-score of 0, it means that it's not deviating from the population mean. And so in this case, the z and sigma cancel each other out because the z has a z-score of 0. So we're left with just the population mean. And so if someone has a height of 0 z's, or a z-score of 0, then that will give us the population mean. In this case, 67 inches. So we would say that this particular student with a z-score of 0 has a height of 67 inches. Alright, that last one was a little bit too easy, so let's make this a little bit more complicated. So let's say we have a person who has a z-score in height of negative 1.25. In other words, negative 1.25 z. The first thing you should note here that our z-score is negative. So that tells us that this particular person will have a height that is lower or less than the population mean, because it's going to go in the negative direction on our number line. Alright, so we can take this information along with the population mean in the standard deviation, and we can solve for the height of this student in terms of inches. So x is the individual height in raw scores, in this case in inches, and it equals z times sigma, so the z-score times the standard deviation. So we'll take negative 1.25 and we'll multiply it by 4.13. And we'll end up with negative 5.16 inches. So negative 5.16 inches plus the population mean, or mu, so plus 67 inches, would give us a height for this particular student of 61.84 inches. And that would make sense because we had a negative z-score, so the height should be less than the population mean. In this case it is. 61.84 is less than 67 inches. And so we can take our formulas and we can take standard scores or z-scores, and we can calculate for raw scores, in this case for heights, but it could be for a different variable or different unit of measurement depending on what we're measuring. Or if we have the alternate formula where we're solving for z-scores, we can take a raw score and turn it into a z-score or a standard score. So you should be able to do both of those now, given the formulas that you have. And remember, there's a formula sheet on Canvas that you should already have printed out and should be studying as well.